Morning, guys. So, welcome back to this week's session. Last week we were talking about operating systems and applications, and we got into specifics with those. So, this week we're going to focus on a specific application but also on databases. We talked a little bit about database in class before when we were covering Microsoft Access. So we're going to be reviewing that as well. But the main topic for today is database and database management systems. So a database is basically a collection of data stored on a computer system, and it is actually controlled by a database management system. Last week we talked about how software was invented or created because it allowed us to be able to interact with a computer, right? Because it's not like we have control over the electricity and the processing that happens in a computer. And again, as good or cool as it would be to be able to control what happens in a computer with just our minds, we can't. We're not able to do that. So we need some way to interact with the computer. And with all applications, we also need some way to interact with the application itself, right? So even with Microsoft Word, I need an area to type out, just as I've typed out here. I need an area to include all the features that Microsoft Word can do, which is what you see up here. I need a way to be able to increase the size of the text or decrease the size of the text, to align it a certain way, and all these features. I need some way to interact with it, right? And a database is no different. A database is very similar to a computer system. It's basically data and information, and it's stored in one place. There's copies that you could make, there's backups, but all in all, this data is stored somewhere on the computer system. And again, we can't just touch the computer with our hands and be able to see this information. You probably go crazy if you were to able to access a database and see all the information in there, because we're talking about petabytes and petabytes of memory. What is a petabyte? It's a lot more than a terabyte. And all this information that are stored in databases are basically your information. We'll get to that in a minute. So you need a database management system to be able to interact with your database, to be able to manipulate the information, and basically get information that doesn't overload, and also to get information that you want. Alright. So how do we do this? How do we get the information? Well, we query it. A query is an object used to retrieve information from a database. If you look at the picture here, a database is usually represented like if you're going to draw a figure or a diagram of a database and how it interacts with other systems. It's usually in the shape of a cylinder and also with some layers on it, but usually a cylinder is enough. And you draw the diagrams where the different systems interact with a database. And almost all, if not all, internet services and websites and so forth, you'll always see a database in the diagrams, or if you don't see it, it should be there, or it does incorporate a database in some way. Our DBMS, which is short for Database Management System, allows us to insert data into the collection, because if you have something that can store data, you need to have a way to be able to put data into it, right? You have your database, you have your collection, but if it's empty, then it's not useful to anyone, because if you go and look for information in there, well, it's empty. So we need a process for us to insert the data into the collection, and DBMS offers that. And we could also use a database client to do that as well, but We'll get there in a little while. But why? Okay, so why are databases really important? Databases house really crucial information for some, and it can house really like non-important information. It really ranges from both spectrums, from both extremes. Database Databases, depending on the company, collect and store certain information. So, for example, if you had a database for a company like, let's say BWS or BEL, they have customer information, and that would be important, right? Because if you're not in the system, then you might not be eligible to get electricity, or maybe you're not getting electricity right now. So that's a crucial set of information. But if you compare it to, for example, a customer at Costco in the US, you know they issue Costco cards for members to be able to shop there. Well, if you didn't, now you know. You need the card to shop at Costco. And if you're not in the system, then maybe your card won't read when they scan it. But it's not that crucial because Costco isn't the only shop in the world. So if you can't go to Costco, then it's not that crucial because you can go to another store. So databases store information on a wide spectrum. And that's why it's so catastrophic for databases to go down, specific databases. If Social Security were to go down, it affects countries. It doesn't just affect one person. For Belize, we have a small number of Social Security recipients compared, and that's again compared to places like the US, Russia, China. If the Social Security systems in those countries were to go down, it'd be really bad for a lot of people, especially elderly people who depend on that little extra that they get from Social Security or so forth, right? And so that could be catastrophic. We're talking about, people's lives being affected. If you compare it to right now with the COVID-19 pandemic, just the simple fact that we can't go out, well, now we can, but before, it affected a lot of people. A lot of people were affected financially by this. They have families that live paycheck to paycheck, and because of this lockdown, maybe work wasn't there. It's a lot like databases. If the info isn't there and if it just drops, then it's like you can't go to work. Because why? Well, there's no account or there's no information here that you work here because the data is gone. Or maybe simple stuff like, oh, we can't pay you this week because the database is down. We don't have your bank info. We don't have stuff like that. Or we can't even get money from our accounts because the database is down, and we need to monitor when money is coming out or going in. So that's just finance. And how about when it comes to hospital data? All right, you go to the hospital. It could be life or death situations. You'll need to know what's going on. A lot of things that hospital do is if they can't rely on things electronically, well, they go back to just pen and paper system. There was, and there probably is, many attempts from hackers to access hospital databases or access hospital information, because nowadays you could actually shut down a hospital remotely if you know what you're doing. And I think that did happen last year or the year before that. Hackers held a hospital ransom, and basically why? Because they wanted to be paid or they wanted money. And what was happening? Well, people's lives are at stake. If your doctor doesn't know what's wrong with you, how can he or she treat you, right? So that's why databases are so important, because they store a wide spectrum of information. So coming back to the DBMS, basic things are needed to insert the data into our collection. So when you go to the doctor, you fill out forms. Maybe not here in Belize, but in the US or probably more developed places, they take that information and then they enter it into some database in their hospital files. The DBMS also removes data from the collection. In many companies nowadays, people don't really delete the information as often, at least for very large corporations, because data is power, or data is money as well. they tend to keep the data because the more they know about someone or the general population, the better they can use the data to either create products or refine services and try to use that data to make their product or service better, so people will want to use their service. And then finally, to query data. If you have all this data in your database, that's fine, but if you can't get it back and be able to report on it or analyze it, then what's the point, right? So you query your data using a set of constraints, which is limitations, because if you look at the users of YouTube alone, they have about 2 billion users worldwide, and every month there's like a few millions of views, and every time you watch a video, that's data being stored in a database because they check your account. There's gonna be able to say, okay, you watch this video, this count as a view for this YouTuber, and so forth. So if you were going to go and say, well, give me the information on this video, and you could easily say that one of the most popular music videos have 1 billion and so views. You don't want all billion user accounts all at once to say, all right, who watched it. You want to limit those by constraints so that you don't get overloaded, but also you get useful information. If you're gonna do an analysis on the most viewed YouTube video in the world, at one point it was Gangnam Style, I think. It hit 1 billion views, and then it went to Despacito and so forth, right? And again, you guys know this because you use YouTube. But to perform a proper analysis, you don't want to just say, well, give me all the people that watched it. No. You use data in a database to perform worthwhile analysis. I said it just now, you use that data to see how you could improve or use that information to your benefit as a company. And how do you do this? Well, you start by isolating what you want. For example, if you start isolating videos based on viewers, and you want to know, all right, how many of them are under 18? Like, why do you need to have them under 18? It all fits on the scenario you're trying to go for. I could, off the top of my head, say that, all right, I want the people under 18, which accounts, or at least how many people watch this video, to say, all right, how many or how much censorship should I consider when it comes to these videos? Because if you're under 18, you're technically not an adult, so you need to be censored. I think it's even by law now with the internet, especially with YouTube, to censor certain material for children. Alright. Another thing, alright, if I add the constraint for people that are under 18 and also for people only living in New York, my data starts to shrink, it starts to decrease, because then what are the chances that there are people under 18 and living in New York? It's not going to be 2 billion, right? It's going to be less than that, and it makes the data become more, I guess, lack of a better word, analyzable and comprehended. So why New York? Again, it depends on the scenario. Off the top of my head, different states have different laws. So it's not just one law for all the country of the US. If you go to the US and you live in different states, you should have different laws in some of these states. Maybe New York has stricter restrictions for children underage watching videos. Who knows? And then also, how many of these users are males? You know, for what reason? Maybe you're trying to see a gender comparison, how much males watch these videos compared to females and so forth. And then another search criteria, if we have all of this bundled into one, well, then the data becomes more manageable, because how many people here are under 18 living in New York, male, and using YouTube for at least 5 years? That means you had to have been using YouTube since you were 13. So that gives me a very specific set of data following specific rules, because that's the scenario that I'm looking for. So now it's not 2 billion, but it's probably maybe like, let's say 100,000 or 200,000, right? And I could make comparisons and reports using this data set. And basically, if 2 billion people are using YouTube, and it takes me a second to read one person's info, and trust me, it's not just 1 second, because they're talking about the person's name, username, Gmail account, location, cookies, browsers, all of that. But even if I only just took 1 second to watch their info, in 2 billion seconds is about 80 years. It take you your entire life just to read the information of all the users on YouTube. So that's where database comes in. It gives us a way to manage the data. It gives us control over the data. Alright, so what you see here now is some statistics on YouTube, and basically all these statistics online and all the information you could find on a census and report. Go online and just search statistics on anything, and more than likely it's a database that the information is coming from. You have 1 billion plus users on YouTube. 50% of the views come from mobile devices. How do I know that? Because the collection of data is stored in a database, and then they analyze that information. The query of that probably looks like, give me all the people where they are watching from mobile devices, right? Where is YouTube localized in 88 countries? How? Give me a count of the countries only that YouTube is localized. Depends how you ask. YouTube reaches more 18 to 34 year olds. How do we know that? Well, we look for people between 18 and 34 years old. Or we just look based on age. Well, how many people watch YouTube? Give me the ages and give me a count of those ages based on the age itself. So how many are 1 year old? How many are 2 year old, 3, 4, 5? All it depends on the scenario and how we ask for that information. Right? YouTube what people watching YouTube on TV has more than doubled. Right? What's this saying is, okay, how many people are watching YouTube on their TV? Well, smart TVs have become a lot common now, so now it's increasing that you're not watching on your phone, but people are also watching YouTube on TVs, right? So imagine all companies in the world, they have their database, they have their statistics, and they use this information to report on many things, either on finances, profits, income, and so forth. So databases affect everyone. It's not just business, because in business it's easy to tell that, okay, databases help finances or businesses on generating profit, or even just recording profit, or just analyzing profit and services. But even in the scientific field, people use databases to store results from their experiments, and then they analyze those results and they put it on a graph to basically track changes or deviations or different environmental factors that affect your experiment. Obviously, database plays a role in IT, because guess who's the ones that's managing the database? Us, IT professionals, database managers, data analysts, and so forth and so forth, right? So databases basically are involved in all fields, because all fields need some place to store their information. Hospitals, social security, government, entertainment, even movies, licenses, car licenses, basically anything you could think of, you could make a database out of it, because you want to store information about it, right? So we'll pretty much finish up here. One of the structures that most databases are created as are called relational databases. There's other databases out there that have emerged, like, for example, NoSQL, MongoDB, which aren't relational databases, and they work differently structurally or architecturally, but I won't get into that too much. We just need to cover relational databases here. And as the name suggests, these are basically databases that have relations to one another, meaning they refer to one another and make sense based on the info that's stored. Right? In a database, you'll have a table, and you're not limited to just one single table. In this case, we have an employees table, and we have info that's all related. So You have the first name and last name of a person. You also have their company that they work at, and you have their email address. These are related to the employees because you know what their email address is and what company they work at. You could have another table that says salaries, and then you just store the salaries for these people here, and they relate because the salaries depend on the person and what they do, right? So that's why we have relational databases and basically have data that coincide or relate to one another. Each row is considered one person or one object in a database. That's the horizontal line. So in this case, Nancy, all this information in this row belongs to Nancy. That's her email address, that's her ID of the company, and that's the company she works at. Same for Diana, same for Anne. That line of info are theirs. And then the columns, the vertical lines, are also called fields, and they define the data beneath them. So what are these on this column? Well, there's email addresses. What are these on this column? The first names of those employees, and so forth and so forth. Alright, so that's pretty much what we'll be covering today. We talked about the importance of database systems and the importance of database management systems, right? We talked about why it's important to have databases. We talked about how we access the database and how we get information. And we talked about how databases are represented on diagrams, defined what a database is and what a DBMS is. So I'll end it here for today. I'll post the homework, the assignment on Thursday as usual. Make sure you finish that up. We are about 3 weeks away from the last day of classes, or actually 2 weeks if you think about it. So make sure you finish up the assignments if you have not already. I know some of you guys need it. Alright, you know who you are. Finish the assignments and let's see if we could bring up some of those grades. Alright guys, stay safe, have a good day. See you Thursday.